Okay, welcome. This is the first of the homework discussion videos. We're going to start here in 1.1. I've had, looks like about 9 questions asked, so we'll start here on number 6. Number 6 says the set of numbers between but not including -6 and 6 can be written as follows. And then your options below are all in set builder notation. So the set builder notation is always open a bracket. That means that we have a set. We're identifying just an x values, right? And then we give a condition on those x values. And that condition is given to us in the problem. It's all of the numbers between, but not including -6 and 6, right? So that means I'm going to write this out in a tripartite, I can't remember what this is called, but it's all of the numbers between -6 and 6, so you can think of it as x simply being between those two, right? Tripartite is what that word was. And that's our condition right there, right? And it's specifically less thans because it's not including those two numbers, but this tripartite is 2 inequalities in 1. That first one right there says x is less than 6. The other one is, if you read it from right to left, which most people hate to do, but if you read it from right to left, it changes this from a less than to a greater than. That is to say that x is greater than -6. But you can think of the tripartite as simply saying that x is some number between these two numbers. Right? So that's our answer. That's one of the answers in the bottom of the in the options there. So that's number 6. Let's take a look at 15. Again, I'll go kind of maybe quickly between one problem and the next. The camera that I'm using has like a 25-minute time period where it'll start doing a second file, so I'll try to avoid having 2 files. But if you need to pause between 2 problems, just feel free to pause. But let's go with number 15 here. 15 says we've got 2/5 plus 1/2, and that's all over 1/10 plus 3/15. It's weird to see a 3/15 because that could have been simplified, but that's all right. We'll keep going with that. What I want to do is turn the numerator's sum of 2 fractions into a single fraction, right? So let's just take a look at this off to the side. That is to say I have just this 2/5 plus 1/2. In order to combine 2 fractions, I need a common denominator. The common denominator here is 10, which I can obtain simply by multiplying the top and the bottom of the left fraction by 2. That turns that into 4/10. And I can multiply the right one by 5/5, which turns that fraction into 5/10. I can now combine these, that is 9/10. Over whatever happens in the denominator, but the nice thing is now I just have a simple fraction here for the numerator, and I'm going to do the same thing and get a simple fraction for the denominator. So if you need to pause this, I'm about to lose all that work on the right hand side. Pause it now. The denominator here, I'm going to do the same thing. This is 1/10 plus 3/15. I can get both of these to be a 30, right? There is actually something better you can do, and that is to say, well, 3/15 could be simplified, but let's just roll with this for now. I can get these to both be 30s, and I can say I'll multiply this by 3/3 to turn that into a 3/30. And I can multiply this by 2 over 2 to get that to be 6 over 30. And so when I combine those, that gives me 9 over 30. The reason that's helpful now is because I have a fraction divided by a fraction, and when I have that, I can take that bottom fraction and simply flip it and turn this into a multiplication. The top stays the same, the bottom turns into 30 over 9 as a multiply, and then I can simplify. 9 and 9 cancel, leaving just 1s. 30 and 10 cancel, leaving just a 3 up there, so I have a 3. 1 times 1 in the denominator is 1, and so I should just get a 3 when I simplify. And that's the answer we're looking for. Okay. Let's look at, the next one we had was 23. Okay. 23 says, state whether the inequality is true or false. And we have a square root of 3, and then it's either greater than 1.6 or it's not, right? And there's two ways to do this. You can take the square root of 3 and plop it into a calculator, and if you do, you're going to get something like 1.7 something something, and that'll then clearly show that it's true. If you don't have a calculator, another thing that you can do is square both sides. Right? If I square this side and I square this side, they're both positive, so if one's greater than the other, their squares will also be greater than the other. The square of the square root of 3 is just 3. And if I take 1.6 and square it, I get, I want to say 2.56. Check that on a calculator. I think it's right. But this then is true, right? And therefore, your answer here is true, right? And again, there's two ways to do that. You can just plop 3 into a square root in a calculator and get that 1.7 something something something. Or you can square both sides and see that they're squares. Make this true, and therefore the original ones make it true as well. All right. Let's look at 24. 24 is similar. (24) says, is the square root of 5 greater than 5 halves? I'm going to write this 5 halves as 2.5 because it's easier for me to deal with a decimal than it is this improper fraction. And I'll do the same thing here, right? I can either throw root 5 into a calculator and get something like 2.2, I don't know what it is, but or I can square both sides. The square of a square root gives me 5, right? I'm talking about squaring this, squaring that. But 2.5 squared is 6.25. This is false, therefore this was false. Okay. Okay. Let's look at 27. (27) asks you to relate 3.35 with a bar over it to 3.35 with a bar over it. The difference though is on the left, the bar is over the 3 and the 5. On the right, the bar is over the 5 only, right? So that is to say that my number on the left is 3 point, and the bar over the 3.5 indicates that the 3.5 repeats over and over. So is that greater than 3.35 repeating, but the bar's only on the 5 over here, so the 5 repeats forever and ever. right? Now, one number is greater than the other number depending on the first digit that's different, right? So if I look at the ones place, they both have a 3. So far so good, they're the same. The second digit in the tenths place is a 3. Those are the same. In the hundredths place, we have a 5 and a 5, but in the thousandths place, we get something different. This one's bigger, meaning the number on the right is bigger, and therefore this is false. All right, let's look at 34. 34 says find A union B. If A is the set of x values given that x is greater than or equal to 5. Right? And B is the set of x values given that x is less than 20. Right? So we're looking for the union of these two things, and it's nice to have visual representation of what's going on here. So I'm going to draw these out on a number line. The first one, A, is all of the numbers greater than or equal to 5, so I'm going to write a 5 here. To be equal to or greater than is to have a closed circle, or sometimes you'll see it as a bracket, and then everything shaded to the right. Forever, onward, forever, to infinity. Okay. That's A, that's the visual representation of A. Here I have B is all of the numbers less than 20, so here at 20, an open circle, or sometimes you'll see it as a parenthesis, specifically that way because it's the numbers less than 20, and so I would shade those to the left, right? Now we're looking for the union of these two things, which is the more inclusive of the two conjunctions. So if I smash these two lines together, everything that's on one line included with everything on the other line, you can see that's going to be everything. Every single number on a number line is either here or both places. And so that is everything, right? Smash them together, you get all of the numbers up to 20 from the bottom guy, and you get all the numbers past 20, including 20 from the top guy. So that's everything. And we can write everything. We can write all real numbers in a couple of ways. This double bar R means all real numbers. It's everything in there, right? If you're asked to write it in interval notation, that is from negative infinity to infinity. And infinities always have parentheses, so it's that. There's also a question on 35, which uses these same two sets, except we're now looking for the intersection, right? But again, since it uses the same two sets, I'm just going to use these two same sets and run with them. If I'm looking for the intersection, then the intersection is less accommodating, it's more exclusive. It's only the values that appear in both sets, right? So numbers like, say, I don't know, let's call this 10. The number 10 is in the first set, and it's sitting right here in the second set, so it's included, right? So right off the bat, we should know that the numbers to the left of 5 are not going to be included because they're not in the first set. And the numbers past 20 and 20 itself are not going to be included because they're not in the second set. Which numbers are Well, all of those numbers between 5 and 20, those are in both places. And so I'm going to say that they're all of the numbers between 5 and 20. And I'm going to include 5, because 5 is in the first set, it's included. 5 is also in the second set, because it's less than 20, so it's there, and so it's a bracket. Right? What about 20? Well, 20 is in the first set, but it's specifically excluded in the second set, so it is not invited to the party. Right? And so we have our interval notation, 5 to 20, bracket on the 5, parenthesis on the 20, and that's that. And the last one was 36. Thirty-six says it's a union, so we're finding A union B again. Again, I have an A is the set of x values here that x is greater than 12. And B is the set of x values given that x is less than negative 18. So again, it's nice to visually represent this. I'm going to draw it out. The more you do of these, the less you'll have to draw them out because your brain's going to all of a sudden just start picturing it. X is greater than 12. There's 12. X is specifically strictly greater than 12 is an open at 12 and everything to the right. B is the numbers less than negative 18, so pick a negative 18. Make sure these numbers make sense. Don't put your negative 18 way over here to the right of your 12 from the previous line, because when you think about smashing these two together, they should line up, right? But to be strictly less than negative 18 is an open there and everything to the left. Now we're looking for the union here, which is to say, take these two lines and just smack them together, and everything that's here and everything that's there ends up in the combined part of it. So that is to say, all of these numbers to the left of negative 18 are there because they're here. All of the numbers to the right of 12 are here because they're there, right? So that's visually what we're looking at here. To write this in interval notation, I'm going to have to write it as the union of 2, and so that is from negative infinity up to negative 18, with a parentheses because it's excluded, union with the numbers 12 to infinity. And that's what we're looking for on 36. And I want to say 37 is probably, yeah, it's the intersection. So let's just do it because we have time here. 37 says find the intersection. And the intersection then is taking these two, smacking them together and comparing. But all of these numbers here are not upstairs. And all of these numbers here are not downstairs, so what is in the intersection? Nothing, right? So we would typically write that as the empty set. All right, hopefully this was helpful. I appreciate you guys posting your questions in the Canvas discussion boards. Keep that up, keep doing that. If you have questions, post them in there. Material will get a little bit harder, so I'll expect to see probably more questions here and there. And if you can answer some questions, that would be awesome too. It's a lot more valuable to you to answer a question if you can, because it makes you have to think about what you're saying and does it make sense and can you portray this to another human being. So very valuable. So keep it up. Good job. Proud of you guys so far. And I'll see you for the next one.